So, what do you guys want to work through? You guys pick.
C.
1C, and then we'll pop over to 4. Is 4 the big shape? Yeah.
4.
Yeah, we'll do 4. So I heard C first since I'm here. We'll do C, and then we'll go do 4. 4 is the biggest one. 4 is definitely the hardest one on here. It's very much like the tile patterns that we were trying to do with the magnet stuff. So these ones here, they're just order of operations. So just above the tree, up 1 from there. That one. Yep. That's it. Okay, so order of operations is going to be your best way to do it. It's not the only option. There's going to be times when you can do distributing. You can have some choices on the first one, but this one is just order of operations. So first things first is I'm going to simplify what's in the parentheses. Holy chunky pen, Batman. There we go. I'm going to simplify what's in the parentheses. So we're going to do 5 minus 1. And 5 minus 1 is 4. So we're going to bring down the rest of it. The 3 and the 2, there's nothing I can simplify inside each of those parentheses. What does it mean when they're smashed up together like this? Multiply. So we can put this as 3 times 2 minus 4 plus 4. Next thing in order of operations, we're going to do our multiplication. So 3 times 2 gives us 6. Going to bring down the minus 4 plus 4. Then we're on to our adding and subtracting. Adding and subtracting left to right. So 6 minus 4 plus 2, we're going to wind up with what as our answer? 6. Six is our answer here. Let's look at 4 real quick, because 4 is by far the most obnoxious one on here. It's all about trying to see a pattern. What do we notice pattern-wise? Say it again?
8, 14, 22.
Yep. 8, 14, and 22. That's how many cubes there are there. So there's 8 here, there's 14 here, there's 22. That'll let us kind of check any kind of expression we have. What do we notice about the shape overall of these guys? They're getting bigger by 1 on the what? Like bigger by 1 square? So, oh, you're talking about these little gaps down here? Yeah, the gaps are bigger by 1 square each time. And if this is figure 1, and this one's figure 2, and this one's figure 3, if I was looking for figure N, how many would we take away from the bottom to find figure N? If this is figure 3, how many do we take away? And say we took away 3 right here, right? We took away 2 right here. We took away 1 right here. So whatever is happening with the big red shape, at the end, they take away N. So we're going to remove whatever the number is of our figure.
What do you mean, like each time?
So if we think about this as one big red shape. Let me switch one of my colors to red so I can color it in. So if this is, ooh, I want a highlighter. if this is still a part of it, and they just take away the end at the end. They're taking away 1, they're taking away 2, they're taking away 3, left to right. This one lost 1, this one lost 2, this one lost 3, right? So is there a way we could build the red shape? What's that red shape there? What shape is it? A square, right? If we're trying to find a square and we're counting the boxes inside of it, we're looking at length times width, right? That gives us a rectangle. Or this, the side of the square squared, right? Does that make sense? What is the length of the side? So what's the length of this side? 3. What's the length of this side? 4. What's the length of this side? 5. Can I relate those to these numbers somehow? +2. Good catch. So the side I can write as whatever the heck my number is, +2. So we can write this as n plus 2 squared gives us big red shape. Hole in the bottom comes from the minus n. So look for big shape that's changing. Look for things that maybe don't change or holes that are cut out. Okay? That gives us our expression. That is the hardest part right there. That is 100% the hardest part of this.
Where should be +2 again?
Because we have 3 on this side, but it's figure 1. 4 on this side, but it's figure 2.
Oh, okay.
There we go. I heard that one
So
quick.
look at the where it says figure.
On the number at the bottom, yeah.
Oh.
Because we noticed that these sides were getting bigger by 1, and that was kind of the trend we wanted. So we're finding the area because that's the number of blocks. Okay? And since it's a square, it's squared instead of length times width. Length times width is gross. Okay? So finding that equation is the hardest part. When you're looking at something like this on like an assessment, if you get stuck on the expression, give me an expression and find the figure for your expression. Give me something I can work with. Don't leave things blank. Try stuff. Make something up if you're stuck entirely. Okay? Because when we're talking about how many cubes would be in the 22nd figure, so if n is 22, we're going to grab a calculator and get 22 plus 2, so 24 squared minus 22. And we're going to type it in the calculator, which I think I may have done it wrong on the answer key, but that's okay. And actually, let me see if I can get my calculator to pull up on here. Got it. Okay. But it didn't do the thing. Oh, it's because it won't let me. Okay, I can't get my calculator to come up. So just type it into a regular calculator. And you could type it in with the parentheses exactly as it is. 22 plus 2. Close it. Squared. Minus 22. And I get 554. So it's all about trying to see the patterns, trying to write an equation. Homework 2 had a lot that were very similar to this. Eventually, that's all what it was about. It was about finding those patterns and writing expressions for it. Or at least matching expressions to it.
Wait, how you doing? I got 576.
Did I type it in wrong? Looking for 22nd figure. 22 plus 2 in the parentheses squared minus 22. Let me see where
Okay.
you got it? Okay. Did you get it? Oh, you're looking at something else. Okay. So this by far is the hardest one. By far on this test. Okay. It's also only going to be worth 4 points because it's graded according to a rubric where we talk about 2 points for do you know what you're doing, 2 points for did you do stuff right. So as long as you do something right, you'll get points. Okay? Do something. Show me something that you understand. If all we see is that something is being squared, give me that and I can get you points for it. Okay? It's only these kinds of questions are only going to be 4 points. So they're not super duper stress, stare at it for 30 minutes and forget all the other questions kind of level stress. Okay? Yes, dear.
So 22 would be in.
Yes. Yes. And you don't have to use N. You can use X if you like it better. You could use a heart emoji. I genuinely do not care. Okay? It's type it into your calculator in place of whatever variable you chose. Okay? Again, 4 is by far the hardest. What else do you guys want to work through? 5. Let's look at 5. So this one's real similar to the cell phone discussion we had. We had the iPhone 64 gig versus an iPhone 32 gig. I don't know the exact prices, but I know that the 64 is going to cost more. So what we have, bless you. I don't like that blue. I like that blue. What we know is that B is bigger than C. B is bigger. Oh, I don't like that at all. Don't do that. Okay. I know B is bigger. They've told us that. So which one's going to be bigger? The sum of a big thing and a small thing, or 2 small things? Big and small. So this side's going to be bigger, so this one is true. And justify can just be because B is bigger. And it's just addition. It's just pluses. That's fine with me for justification. Whatever was in your brain and how we told. B was bigger. There's a C on either side. They told us B is bigger. We could have subtracted C from both sides and solved it that way. Okay? Just look at it piece by piece. I have 472 plus B versus 472 minus C. Which one's going to be bigger? The plus. This side's going to be bigger. So this one is actually false because they have the inequality facing the other direction. Because adding a bigger number is bigger than subtraction. And there's not like specific words you need to use in the justify. It's what's in your brain, put it on paper. Whatever you use to tell how which one was bigger, give me a piece of that. Because unfortunately, my psychic powers haven't come in yet. Cross our fingers, because then we don't have to keep showing work. But they're not in yet, so you got to show me something. Let me into your brain. All right, B times C and C squared. Which one's going to be bigger? I'm going to say, because remember, it's a big number. Think of it as an area model. Big number times a little number, or little number squared. Which one's bigger? BC. BC versus CC. That side's going to be bigger. So this one is also false. And justification could be the area model that I just drew there. We know that B is bigger, so we can put B as a long side on a rectangle times a little B side. You guys can also pick variables and test, or pick numbers and test it. As long as we don't test with 0, 1, or 2, you can plug in numbers to test stuff. That's totally fine. 5 times 7 is bigger than 5 squared. Ten times 5 is bigger than 5 squared. So pick a B bigger than C and plug in variables. It's totally fine. Okay, so you're just testing through stuff. Watch carefully though, because now we're into a fraction-y guy. 1 over B and 1 over C. Which one's going to be bigger? The C one. Because 1 over C is cut into fewer pieces. I have 1 pizza to split among my 10 friends, or 1 pizza to split among 5 friends. I would rather split a pizza with 5 people because I get more pizza. Okay? So fractions either pizza with friends or cookies with friends. Also, why you can't divide by 0, because I cannot share my cookie with my non-friends. Okay? All right, the bottom one is very, very similar. It just looks really scary because we've got squares, we've got fractions, things look gross. Same kind of vibe. Which one's going to be bigger, B squared or C squared? Just the B squared or the C squared, which one's bigger? Just if we look here, B squared versus C squared. Which one's bigger? B squared's bigger, which means of the fractions, which one's bigger? Now, yeah. This one, again, it's cut into fewer pieces. So it's not necessarily about specific values. You could absolutely substitute in a value. 100 over 10 squared. 100 over 100 is 1. 100 over 5 squared. 100 over 25. That's 4. 1 versus 4. So you can do this other ways. You can do this testing values. You can do this substituting in. Try and do it just observing the shape, like the patterns in the equations. But if you got to substitute stuff in, you substitute stuff in and you don't leave it blank.
So that's false, right?
So correct, that one is false because they've got it facing the wrong way. And this one is also false. So we have true, false, false, false. Number 6. Same kind of vibe. But yeah. Which one's bigger? S squared plus 6 or negative 3 plus S squared? I was going to say, well, I can always rearrange this one to make it look like the other one and have it be S squared minus 3. And that makes it a little bit easier to compare the two pieces if we look at S squared minus 3 and S squared plus 6. So which one's bigger? S squared plus 6. Because it's bigger when we add. That's an exclamation point, not a weird L with twitches. Yup, we're right here. Woo! So this is very much like the card thingy we did, where we're trying to get words that go with the picture, that go with the expression. So when we're looking at the words, sometimes it's easier to take it piece by piece. So we're going to add twice a number to 3, then multiply the sum by 5. So it looks like to me the insideiest piece is this twice a number. How do I write twice a number? 2x. We're going to add that to 3. How do I add that to 3? Plus 3. And then put it in parentheses. And then we are multiplying by 5. So we're going to times 5. And I do not care if we put it at the end or if you put it over here, just pick one. So we're multiplying the sum by 5. This is the sum they were talking about. Okay. How we feel on that part? Because they're weird. They're weird. To do our area model, since we wrote it as a product, I would recommend doing a box kind of thing like this, where we have the 2x plus 3 times 5. That's my recommendation. You don't have to, but you would have to multiply it out then. The next one, I see 2 different ways to do an area model on it. You can absolutely do 5 times n plus 15. Valid. Technically meets the qualifications. We could also notice that we could factor this, and since we like to do that anyway for some things, how could I write this as a product? What can I factor out of both 15 and 5? N. 5. Leaving us with, what's inside? 3. Or 3 plus n. It does not matter which order it's in. So we could also do it as an old school box model. We could do it as 5 times n plus 3. Both of these area models are fine, and you don't need to have both. Both of them are fine. They're both pretty. Okay? I don't care how you do it. If you notice that product, great. If you don't, that's fine. So how could we write that in the expression in words? Boom, shakalaka. I have to zoom this like way far in to be able to write anything close to legibly. So add 15 to a number multiplied by 5. That is perfection. You could also do with our product, add a number to 3 and then multiply by 5. Totally fine. Boo, I'm out of water. This third one, that would be called a technical glitch because it was supposed to actually have stuff on the outside. But so you get to make up your own values here. Okay? So this one is write your own. It kind of looks like this guy. So, I don't know. Somebody call out something. I don't care, variable or number. 4. Give me something else. 8. Give me a variable. X. Ta-da. We made a thing. 4x plus 8. We made a thing. It didn't have any variables on there, didn't have any terms on there. On the test, there will not be a make it entirely from scratch. Because I'm not that mean. Okay, everything will have stuff with it. So this is very much like the one we just did above. 4 times the number. Then add 8. Totally fine. Okay, so I promise there will be stuff you will not have to make up your own on the test. There will not be a technical glitch. I have gone through them. I'm going to try and suck water out of that empty water bottle the entire period. Okay, last one on this one. N plus 6 squared. So in words, we could do add 6 to a number. Then square the result. That's my first instinct with it. Again, not the only option. There's a lot of right ways to put it. And then for our area model here, this is old school, algebra 2, multiply binomial, box method, n plus 6 times n plus 6. This is the reason we cared about these area models at all. It is where the box method was born from. Yes, dear.
I don't know answers. Can you do
Number 3, yes, sir. Okay, this is where the box method is born from. Yeah, number 3 is a good one. It's very colorful. Yes, dear.
I put square the sum of a number and 6. Is that right?
Perfection. Squaring the sum means we're doing that sum first. Yeah, that totally works. Okay, my next request was number 3, so we're on the front page. It's the mixy-matchy. Find the equivalent expressions. And I've got to try and get it zoomed in because we kind of need to see all of them at once. So we're going to match from the number column to the letter column things that are equivalent. They might need simplification. And either column could need simplification. So what do we see that might go together?
I said number 6 to C.
Yep, number 6 to C. Number 2 to B. Absolutely right. If I simplify those both down. Yep. Because we distribute this one out. 6x plus 6 minus x. Then we're going to combine like terms. We've got 5x plus 6. And that matches B. Or matches 2. So they may need simplification. Like number 3 on the first one, in the first column, needs simplification. Same thing with 1. And 4. And 5. 3 to E. Absolutely. I'm with you. 3 goes to E. We simplified them both down and we get 5x plus 3.
I said 5 to F.
5 to F. You are correct. 5 to F. 5 is a tricky one. I'm zooming in on 5. We have to remember our fraction rules. We can uncommon the denominator here and get 3x over 3 plus 9 over 3 to simplify this down, being 1x plus 9 divided by 3, which is 3. So we get this. So sometimes they're a little tricksy. All right, we've got 1 and 4 left to match. 1 to D. Yup. I'll grab orange. 1 to D. And do not just assume process of elimination that 4 goes to A. You got to check it. So this is where we're going to use that area model that we've, been talking about, where it comes from. See if we can remember how to do that. X plus 2 times X plus 2. If we multiply that out, old school algebra 2 style, we do get exactly that phrase. 4x plus x squared plus 4. I'm trying to manifest water to magically show up in that water bottle. It is, I think, I could put a paper towel in there and it wouldn't have anything. But I'm going to keep trying. Optimism. Okay, so this one gets all kinds of ziggy-zaggy. But it's all about that simplification process. Distributing, simplifying, combining like terms, keeping our order of operations straight in our head. Do we feel good on our factoring stuff up here or distributing with the boxes?
Can we do it?
Yeah, let's do it. Okay, so I'm gonna sit down because my handwriting sucks and my wrist hurts. All right, so when we are multiplying 9 times 3x, what do we get that goes in this box? 27x. What's gonna go in this box here? 9 times 5? 45. So when it says to write it as a sum, all we gotta do is add these guys together. 27x plus 45. Then looking over here at our factoring, what did these two pieces have in common that I can pull out a common factor? 4. Both of those terms are divisible by 4. So we're looking for the biggest thing I can divide both by and wind up with no fractions. That's going to leave me with, out on this side, what's going to go here? X. And this one? 7. Boom, shakalaka. So writing it as a product, we have 4 times X plus 7. All right, let's see. Yeah, let's look at it. I think we've got just about everything aside from the factoring and another simplifying thing. So 1B, that's an excellent choice. What do we need to do here? Distribute. Distribute what? X. To what? So we're going to take the X to what? Y. And is that it? Or do we take it to the other Y? Just that first one. X, Y. Plus X, Z. And that plus Y just pops down. Can I simplify that any further? No. Please do not smash things together that are not the same. Okay. So 1 is an order of operation, or 1A is very similar to this, order of operations. You should wind up with an answer of 3. Then I think down here is factoring, just like we did on the box. Just be careful. And this one is another simplify. Simplify them down. Or follow this out. If you write down all the steps, you'll find some of the steps in here that are equivalent. Okay? So it's all about noticing equivalent expressions. So order of operations will give you all kinds of things. Because we have about 8 minutes left. You guys want to have a little bit of time to work on it? Or you want me to go through this one? You feel good, or you go through it? Is that what you said? Go through it. Okay, let's do it. So let's look at this one. So we're going to do our order of operations, which means I'm going to deal with the insideiest parentheses first. So this 5 is going to hang out outside for a while. We have 2 plus 7 times 9 minus 2, which is 7. And then we have this other 3 back here, times 3. That's still being multiplied there. Plus 1. Order of operations says we're going to do what next? We did the outside parentheses. We're working on this piece here. What are we going to do next inside this parentheses? Multiply all of this. 7 times 7 times 3. So we're getting 5 times 2 plus 147 minus 4 plus 1. And oh, look, this step is this answer. So that piece is equivalent, and I don't even have to simplify the lefty version. So let's keep going with our simplifying. Let's simplify what's inside the parentheses. We have, helps if I use a pen. 5 times 2 plus 147 minus 4 gives us 145 plus 1. Which gives us 725 plus 1, or 726. Oops, which is this one. There is one more multiple choice in there for you to answer, for you to find. And what they did was they played weird games with the pieces inside the big parentheses. So they took the fact that this was minus 4 and a plus 2 and smushed it together with our multiplication separate. This one, you can type this guy in the calculator. And that's probably going to be it for the day because he's going to talk.
After school soccer activities have been canceled.
Because it's too dang hot.
All boys soccer activities, all games, all practices, all levels, all boys soccer activities after school have been canceled. All soccer players are to go home. Thank you.
Okay, so you got 4 minutes left. I think all you have left are the factoring ones at the bottom of this page and 1A. Everything else we went through together. So you have just a little bit there. Okay? Go through it. Practice stuff. If you want another copy of it, I still have a few copies because I know that sometimes you like to work through it together and then go work through it on your own. But the test is tomorrow. Okay?